Today we're going to be looking at scientific notation. Specifically, we're going to be converting from standard form to scientific notation and vice versa. What we call scientific notation is a way in which we express really large numbers, so numbers with lots of zeros in front of it, or really small numbers, so lots of zeros before it. So 0.0001 would be an example of a really small number. So let's look at how we do this. So we're first going to be looking at how to go from scientific notation to standard form. All we have to do in order to do that is to just sort of multiply our number by the 10 to the exponent. So 5 times 10 to the 2 tells me that this is 500. Another way that I can do that is by taking a look at where the decimal place is right now. And right now, 5 has a decimal place right after it. So it's the same as writing 5.0, for example. So what I'm going to do is, because there's 10 to the power of 2 here as part of my scientific notation, I'm going to move this decimal place 2 places to the right. And for every position that it's moving, there's a 0 added. And that's how I end up with my 500. Notice that I don't have my 10 to the exponent here in my standard form. Standard form is just the way in which we see numbers regularly. Now let's take a look at this example. So 7.3266 times 10 to the 3. Again, same thing here, except in this case, there's not zeros after the decimal place, but other numbers. And that's totally fine. We can use the same rule. So I'm using this decimal place and moving it 3 spaces to the right. And this decimal is going to go between the 2 sixes. And I moved it 3 spots because there's 10 to the power of 3. So now in standard form, this number is 7326.6, and I don't have to write the 10 to the exponent. Now, say you have an exponent, or the 10 to the exponent, that is a negative number, so 10 to the negative 2. My decimal is still immediately after the 5, but this time, because the number is a negative exponent, I'm going to be moving it to the left. 2 spots specifically to the left. So 1, 2. And just like earlier, if I don't have a number there, I can just put a 0. So my standard form, this number is going to be 0.05. Let's try it for this one. So 4.643 times 10 to the power of negative 3. I'm moving this decimal place 3 spots to the left. So 1, 2, 3. So one of these spots is the 4, and then there's 2 more spots right after that. My decimal goes right here. So my answer is 0.004643. And if I wanted, I can also just write this as 0.004643. That works as well. I just put the 0 right before the decimal. Now if I have 1 times 10 to the power of 6, I have to move this decimal place 6 spots to the right because this is a positive exponent. So 1. There we go. So this is how we convert from scientific notation to standard form. What if we have to do the opposite? So if we're going from standard form into scientific notation. The biggest thing that we have to do is move the decimal place after the first non-zero number. So if I take a look at this number, 0.0003, the only non-zero number in this case is 3. It is also the first one. So what I have to do is move this decimal place from where it is right now so that it is to this side of 3. So 1, 2, 3, 4. So I'm moving it 4 spots to the right. And if I'm moving it 4 spots to the right, the decimal place comes right after the 3, which tells me that this is 3. But remember, in scientific notation, our number is in times 10 to the exponent. And that exponent depends on how many spots we had to move the decimal place. So times 10 to the power of negative 4. Why is it negative 4? Because my decimal place from where it is to where it needs to be is 1, 2, 3, 4 spots away. So the next example, 523.0042. Now there's plenty of non-zero numbers, but I need it to be after the first non-zero number. And starting from left to right, my first non-zero number is 5. So the decimal place from where it is right now needs to go immediately after the 5. So I'm going to get a number that is 5.230042 times, remember scientific notation, times 10 to the power of 2. Now in this case, the decimal went from where it is to where it needs to be. It moved to the left. In the first example, it moved to the right. If it's moving to the left, I've got a positive exponent. If I'm moving to the right, I have a negative exponent. So maybe you can try the next 3 examples, and then we can look at the answers together. So pause the video and then play it again. I'm going to show the answers now. So in my third example, the decimal is here, and my first non-zero number happens to be this particular 3. So if I move it over to the right, 1, 2, 3, 4, 5 spots. So my number is now 3.2004, and because I moved 5 spots to the right, it is 10 to the power of negative 5. In this case, I've got 732. The decimal place is not obviously shown, but for every number like this, the decimal place is always at the end. If you don't see a decimal place, you can always assume that it's on the very, very right side. Now that the decimal place is on the very, very right side, I know that it has to be after the first non-zero number, which is the 7. So when I'm converting into scientific notation, I want it to be after the first non-zero number. So 1, 2 spots is what it has to move to the left in order for it to become 7.32 times 10 to the power of 2. Okay, and lastly, decimal place, again, just like the previous question, is at the very end. It needs to go right after the 2, which gives me 2 times 10 to the power of 2.